Okay, so let's take a look at the occluded front and the stationary front. Like I said in the previous video, not crucial, but you are responsible for them. So in the occluded front, you have this. It's a little bit strange, but this happens when a cold front catches up to a warm front, and we'll sort of explain how that can happen in a couple minutes when we look at a weather map. So in this one here, you have cool air, and it starts to push the warm air up on top. I'm sorry, the cold air pushes the warm air up on top of cool air. You're going to get some precipitation forming in the middle here. And essentially you get this like loft of warm air that's over top of cool air and cold air. We actually get these quite a bit in Chautauqua County, maybe more than you might think. And a lot of it has to do with our location on the planet, but more on that later. And then I also want to show you guys a stationary front. This happens when you have two weaker fronts, and what I'm trying to say is you have two fronts coming that are not particularly strong, the cold and the warm, so neither one can shove itself on top of the other.
Spectrum Mobile is the
Cool. So neither one can push itself on top of the other, so they end up getting stuck here. And you get some cloud cover that starts off as high cloud cover, and then eventually it will translate into some rain. And it's very still, very sticky. We usually get these, I've noticed, in August around here. I'm not exactly sure why. I wish I had a better answer for you, and I probably should because I'm an earth science teacher. Oh, all right, sorry about that. I should know. I should know the answer. Oh, nope, sorry, I'm back on this. Sorry guys, I should know why we have the stationary fronts in August when we do, but I really don't. I noticed that since I moved here, that's when they tend to pop up, and they're real sticky here. Like, they don't feel very good. There's very little wind, some pretty high clouds that look a little menacing, but eventually we'll get rain from them. So let's talk about the weather fronts that you absolutely have to know, which is the cold front and the warm front. So let's take a look at the animation here. So once again, here's our cold front coming in. It's very dense air. It pushes the warm air up. The warm air rises. It produces unstable clouds usually, which is, it just means like you have warm air and cold air trying to mix. And you're going to get really thin bands of really intense storms. If they're intense enough, they'll actually be tornadoes. Tornadoes are always associated with cold fronts. So then here is a warm front, and what we have is you have warm air rising above the cold air, and it's pushing its way out, but it's taking a while because the cold air is more dense. You're going to get all this rise, expand, cool, condense here. There's the wispy clouds. There's the precipitation. So usually you're going to get like a whole day of rain here instead of just like a storm that's only going to last 10-15 minutes and then be over. Okay, a couple things too, just before we leave them behind. There were questions on your lab about the yellow lab about how the mountains of Hawaii might impact the precipitation pattern. So I did want to mention this to you. We call this Windward and Leeward sides of mountains, and essentially what we have here is when you have a mountain range, the air is forced to go over it. So what's going to happen is air is going to come off of usually a body of water like an ocean. It's carrying a lot of precipitation with it. When the air has to get up over the mountain, it's going to have to rise, expand, cool, condense. What it's going to do then is the clouds and the precipitation are going to happen on one side of the mountain, and by the time the mountain reaches the altitude at which it can cross the mountains, it's cooled off, it's dry, and on the opposite side of the mountain, you're going to have like cool, dry, sinking air. It's like a mini high pressure system that's kind of constant, and a mini low pressure system is kind of constant. We can see this from space, so I'll share with you a good example of this. The west coast of North America. So here I am, guys. It's Oregon, Washington, California. But we have some mountains right here. You guys can see them. These little white things here are peaks. These are volcanic mountains called the Cascades. And air comes off of the ocean here, and it has to rise up above them, and it ends up raining here on a regular basis, but not over here. And you can see that difference in color even from space. And then if we were to drop someone down there, I've had a chance to visit out here a lot because I think I mentioned to you guys I have cousins in Seattle. I'm always shocked that, you know, if I'm in a place like Portland or something and I want to go to Eastern Oregon, how much the landscape looks different from one side of the mountain to the other. So I'll drop us in here. Hopefully it's not like a housing development or something. It is! Ugh! Terrible. Let me go back out to here. Okay, let me just get a little more into the wilderness here. So I want you to see the color really more than anything. So you come into this side of the mountain range and you're sort of driving your vehicle and climbing up. It's usually really green, lots of trees. Yeah, it looks like this. This is actually really pretty. So, you know, you're driving through things that look like this, and you're just definitely aware that you're, you know, kind of entering the mountains and in some pretty areas. Then you get to the other side, which is only, you know, we're talking like a matter of another hour or so, maybe an hour and a half before you cross over into the other side. And when you get there, things just look quite different. They're usually drier, sometimes a little. I'm back into town again, I think. I'm really hitting all the right spots today. But you can even tell here, guys, even this little tiny town, you can see that it's not that same kind of lush vegetation we saw. And if we go just a little bit further, I'll try to, again, get a little more away from civilization so you can see the land. What you'll find is that it looks sort of deserty. And that's because of that what they call it a rain shadow, essentially, because okay, this is kind of what I remember. So you get out of the mountains and all of a sudden you're like, wow, am I in the same state? Am I in the same country? This looks so weird. Because what's happening here, you guys can see this high pressure system, clear skies, cool air, not a lot of precipitation that's able to make it over those mountains. So the vegetation has adapted and responded to that. So really different from one side of the mountain to the other because of this phenomenon of windward side and leeward side. Here's just another couple images showing the same thing. So as the air has to rise up, it expands, it cools, condenses, it rains here. And then the other side is the dry area. So they call this the windward side. You can see it right here. And this is called a leeward side. You actually do have to know that. It's not in your reference table. And then this is also called a rain shadow. You saw me mention that, or heard me mention that word when we were looking at the images just a couple minutes ago from Google Earth. And they call it a rain shadow because it hardly ever gets rain because of this phenomenon happening. And this side gets rain quite a bit. So you have a green side and a brown side of the mountains. And yeah, so that's going to matter for some of the worksheets that you guys do this week. But it's also going to matter for that lab. Now, many of you have already turned that in. I knew when those questions were on there that you couldn't really answer it you couldn't answer them that accurately. So I'm just going to look at what you wrote. And if you wrote something halfway sensible, you're going to get credit for it. But moving forward, we should be able to draw or explain this phenomenon and what's really happening here. So that is it. So you guys, we have work to do this week while I'm gone, and you're going to need this information to get the work done. So that's why I wanted to make sure I went over it with you and showed you what you needed to see. And if you have any questions, you can email me. But for the most part, you should be well equipped to handle what we need to do for this week. Good luck and behave yourselves.